what's the derivative of the sine is the limit when h goes to 0 of the sine of x plus h minus the sine of x, right, divided by h. Well, this is the limit when h goes to 0, and then the sine of x plus h, we can use the formula for the sum of the sine of the angle, sorry. So this is the sine of x times the cosine of h plus the sine of h times the cosine of x minus the sine of h divided by h, right? And so this is, let me see, we have the cosine of x times the limit when h goes to 0 of the sine of h divided by h, and then plus this sine, wait a minute, sorry, this is, no, wait a minute. So then we have sine of x, is this correct? Yes, oh yes, sorry, yeah, that's the problem. This is the sine of x and not the sine of h. Okay, now we have the cosine of x that multiplies the limit when h goes to 0 of the sine of h divided by h, and then we have the sine of x that multiplies the limit when h goes to 0 of the cosine of h minus 1, sorry, minus 1 divided by h, right? We're just taking common factors out of the limit. Okay, now the limit of this is going to be 1, we know that. The limit of when h goes to 0, the sine of h divided by h is 1. The limit of this is going to be 0 because we know that the cosine of h minus 1 is approximately equal to h squared divided by 2, right? And so this is h squared divided by h, you get h divided by 2, which is 0, okay? So this part is going to be 0. So the result of this is the cosine. Now if you do the same with the derivative of the cosine, what you get is the limit when h goes to 0 of the cosine of x plus h minus the cosine of x divided by h, the limit when h goes to 0, and then the formula for the sum of the cosine of the sum is cosine of x times cosine of h minus sine of h minus the cosine of x divided by h, and this is similarly, we get the limit when h goes to 0 of, and then we have the cosine of h minus 1 divided by h times the cosine minus, and then the limit of h when h goes to 0 of the sine of h divided by h multiplying the sine of x. This goes to 0 as before, this goes to 1, so this is minus the sine of x, okay? So the derivative of the sine is the cosine, the derivative of the cosine is minus the sine, as probably most of you knew. Okay, let's do the exponential. Okay, so the exponential is f of x e to the x. F prime is the limit when h goes to 0 of e to the x plus h minus e to the x divided by h. But then we can get common factor e to the x here, gets out. The limit when h goes to 0 of e to the h minus 1 divided by h. But we know that this is 1, so this is e to the x. Okay, that's why the derivative of e to the x is the same function, and that's the only function actually that has this property. Okay, that's a very interesting one. Okay, so we have that derivatives for a lot of our basic functions. We say that the function if a function is differentiable in an interval, right? For every point in an interval, we say that the function is differentiable in that interval, right? And then we can define the derivative function. Okay, so then we have f prime, which is a function itself, right? As we have been seeing, that assigns to each point in a domain it's the derivative of f, right? And it works, the domain of f prime is going to be those points where f is differentiable. Okay, so that's the derivative of f. And also we can do this recursively and define the second derivative of f, which is assigns to each point in its domain, which are those points in which this function is itself differentiable, right? F prime at x is the limit when h goes to 0 of f prime of x plus h minus f prime at x divided by h, right? So it's always going to be the same, right? The second derivative is the derivative of the derivative. Then we can have the third derivative, the fourth derivative, and so on, right? The third derivative is the derivative of the second derivative. The fourth derivative is the derivative of the third derivative, and so on, right? Up until the fourth derivative, or maybe including this one, it's typical to write them like this: f to the parentheses, okay? And then this implies the nth derivative, okay? So then if you have f4 like that, that's the fourth derivative, okay? Fourth derivative.